This is a continuation on section 1.7. Before part A, we were talking about solving absolute value equations, so they had an equal sign. That was part A. Now we are going to be working with inequalities, so something like a less than or a greater than or less than or equal to or a greater than or equal to sign. Before we start working on actual problems, let's take a look at the quick steps. So our task is to solve absolute value inequalities. Step one is going to be to break into two different equalities, much like we broke it into two different equations in part A, where we broke it up like this. And one of them we had the positive number, and one of them we had the negative of that number, right? So we had 5 over here and negative 5 over there. Whatever number on the opposite side of the inequality, you break into two, and one's positive, one's negative. You are also going to flip the sign of the inequality on the negative side. So the positive number is going to have the same inequality. So this is a less than or equal to. And the negative one, you are going to flip the direction of that inequality. Think back to solving inequalities without absolute value signs. Anytime, remember, we multiplied or divided by a negative, we had to flip the sign. Same idea here. Negatives and inequalities are kind of weird with each other. So anytime you break off that negative, that negative half, that's when you have to flip the direction of the inequality. Then you get rid of the absolute value signs and you just have the j and j. So we have j is less than or equal to 5 and j is greater than or equal to negative 5. Now, this, generally, if there was more happening with j, if it was like j plus 1, you'd have to subtract 1, you'd have some solving to do. And then your next step is to graph it. So essentially, we need to decide if this is an and inequality or an or inequality. Think back to the previous section. And we currently do not know if it's an and or an or. So what we're going to do is we're going to graph it and have that help us decide which one it is. So think back, we go back to the number line, smaller number on the left, bigger number on the right. These are going to be filled in circles because of the or equal to. Remember, if it's less than or equal to or greater than or equal to, it's filled in circles. And if it's a less than sign or a greater than sign, it's open circles. And then let's go ahead and graph it. J is less than or equal to 5, that would go that direction. J is greater than or equal to negative 5, that'll go that direction. Remember, when they're going towards each other, it's an and if they're going away from each other, it's an or. These arrows are going towards each other, that's an and inequalities are always written smaller number, less than variable, less than big number. Our smaller number here is negative 5. Our bigger number here is 5. The variable, which is j, goes in the middle, and then we get less than signs here. Now in our problem, it's actually going to be less than or equal to because that's what we started with. And that's our answer. Negative 5 is less than or equal to j is less than or equal to 5. Let's go ahead and do another one. So here we have the absolute value of 4x plus 5 is less than 13. Step 1 said to break this into two different problems. One of them will just say 4x plus 5 is less than 13. The other one, remember, we're going to make it negative, and we have to flip the direction of the inequality. So we have 4x plus 5 is greater than negative 13. Now we're going to go ahead and simplify each of these individually. We have to solve for x here. X has a multiply by 4 and a plus 5 happening to it. Let's undo the plus 5 first. So you subtract 5, and you have 4x is less than 8. So x is less than 2. Over on the other side, we're going to subtract 5, and that's going to give us 4x is greater than negative 18. Divide both sides by 4, so x is greater than negative 9 halves, or negative 4.5. Remember, I stated before that I prefer these inequalities, improper fractions, rather than like a decimal or something. If it's a terminating decimal, like this was just negative 4.5, that's fine. but we should know how to get to this answer as well. Go ahead and write it on a number line. Smaller number, -9/2 or -4.5, don't matter. I'll use a decimal here since it's on a number line. And 2 is over here, 0 would be somewhere over here. I'm not super fussy on it, just kind of give you a general perspective. X is less than 2, it's an open circle going that way, and X is greater than -4.5, that's also an open circle, and greater than would go, towards 0. So they're going towards each other. This is once again and inequality. We're going to put the smaller number on the left, 9/2, or if you wrote -9/2, or if you wrote -4.5, totally fine, is less than. X is less than 2. That's the answer we're looking for. Remember, we know that because it's small number, less than X, less than big number. It's just less than signs because our original problem was none of these have or equal to's. And you put the smaller number, the negative one, over on the left, and the larger one on the right. So this one is going to be the same, but we would have the or statement. I'm going to skip over that. So in this problem, the absolute value bars are not solved for. They're not by themselves. And we are going to have to get them by themselves. So you need to move the other stuff away. We have a +3 on the same side as it, and a multiply by 2. We should undo math in sad math order. Looking to undo subtraction and addition first. So we have 2 is less than X plus 4. Absolute value signs around that is greater than 12. Our absolute value bars are not solved for yet. They have this multiply by 2 next to them, so I need to divide both sides by 2. When you divide by this 2, those cancel. Divide that by 2, you get 6. Now I have the absolute value signs by itself on this side. Now is when I can split it into 2 different problems. One of them is going to be X plus 4 is greater than 6. You just get rid of the absolute value bars and leave it. The other one, X plus 4 is X plus 4 is less than -6. Flip the direction of the inequality and make it negative. So we have X is greater than, subtract 4 on both sides, 2, and X is less than, subtract 4 on both sides, -10. Number line, negative number on the left, positive number on the right. 0 would be somewhere over here. X greater than 2. X is less than -10. We can see this one is an OR statement. It's an OR statement because the arrows are going away from each other. OR statements are actually easier to write. We don't have to think about much. We just have to write both of these with the word OR in the middle. Generally, we prefer the smaller number, which is going to be the one on the left of your number line first. So X is less than -10, or X is greater than 2. And that's our solution. Let's kind of revisit what this is stating. It's stating that X value is less than -10. Make this original problem true. So -11, -12, -13. If you plugged any of those in, this would be a true inequality up here, right? If you plugged in those values in for X. Or if you plugged in anything bigger than 2, so 3 or 4 or 5, those should also make the statement true. I think this is a good pausing point. Go ahead and try this one, see how it works. See if you're able to get it. We'll go ahead and break it up into 2 different problems. One of them just says -2x plus 1 is greater than 9. And one of them says -2x plus 1 is less than -9. Now we can go about solving this. We subtract 1 on both sides. -2x is less than -10. And subtracting 1 over here would be -2x is greater than 8. Now if I'm going to continue with this problem here, our next step is going to be to divide both sides by -2. But keep in mind, this is important, keep in mind, anytime you multiply or divide both sides of an inequality by a negative, right? Like here, we're going to be dividing by -2. Anytime you do that to both sides of an inequality, that inequality has to flip directions. So here it said -2x is greater than 8. Now it says x is less than -4. Notice the direction of the inequality flipped because we divided both sides by -2. It's going to happen over here as well. This will say x is greater than +5. So it's kind of weird. We had to switch it the once from here to here because when you make the negative branch, you have to make the -1, you have to flip the sign. And then we also had to flip it again when we divided by -2. So we'll go ahead and make the number line. -4 is over here. 5 is over here. 0 is somewhere over here. X values greater than 5, open circle going that way. X values less than -4, open circle going that way. I want to point out that the inequalities should always be going away from each other or towards each other. You should never have it like this way and this way again. If they're both going the same direction, that tells you did something wrong. They should both be going away from each other or both be going towards each other. So this is an OR statement. X value less than -4 or X value greater than 5 would be our solution, our final answer. Remember, we're taking those, writing the word OR in the middle. You write the -1 or the smaller one first. There will be this absolute value word problem type of question, and it will be on the quiz and the test. But keep in mind, on your quiz you can use your notes, and on your test you can use a note card so you can properly set this question up. I'm going to give you some information like the ideal weight of a professional baseball is 5.125 ounces. Okay, when you produce something, it's not always going to be 100% accurate, and that's what happens. They have an allowable tolerance of 0.125 ounces. What I want you to do is I want you to do two things. I want you to say, it's going to say like write an absolute value inequality, and then 2 will say simplify that absolute value inequality. So basically, a good baseball can be 0.125 ounces less than this or greater than this, and you need to do two things, right? An absolute value inequality that describes it, and then simplify the absolute value inequality and write it like an and or an or. So the way that you're going to do this is you're going to say, hey, any random baseball that you take off of the assembly line. So the absolute value of any random baseball that you take off the assembly line minus the expected value, okay, the ideal weight or whatever is expected of it. So if it was like, hey, a can of pop is expected to be 12 ounces, okay, that would be 12. This is what we expect it to be. So 5.125 ounces. This has to be, actually, I'm going to do this, minus the tolerance minus the ideal has got to be less than or equal to the tolerance. So in our problem, the absolute value of x minus 5.125 has got to be less than or equal to 0.125. So that would be you writing an absolute value inequality that describes the situation. You just need to fill in this information. The absolute value of x minus the ideal, which was 5.125, has got to be less than or equal to whatever that allowable tolerance is. We should be able to simplify this statement using what we've been doing in this video, where we break this up into two different problems. X minus 5.125 has got to be less than or equal to 0.125. That's one of them. And the other one is x minus 5.125 has got to be greater than or equal to negative 0.125. Solving each of these for x, you would add 5.125 over, and you would get x has got to be less than or equal to 5.250. And this one here would say x has got to be greater than or equal to, I'm adding 5.125 to negative 0.125, 5. Go ahead and put these on a number line. The smaller number is 5. Larger number is 5.250. X values have to be greater than or equal to 5. That's a filled in circle. Greater than, x values greater than 5 would be that direction. And x values less than or equal to 5.250 would be that direction. This is an and statement. And statements are always written smaller number, less than, or in this case, or equal to, x less than or equal to big number. So 5 less than or equal to x less than or equal to 5.250. That would be our answer to the second part of the question. And this should make intuitive sense as well. The ball has to be less than or equal to 5.25 ounces, and it's got to be greater than or equal to 5 ounces. Remember, we read this from x's perspective, so don't read it like 5 is less than or equal to x. That's confusing. Say x has got to be greater than or equal to 5. That makes a lot more sense to us. So your word problems will always be set up like that. There is a couple of practice questions like that in the textbook. Remember, you just take this part. If you write this on your note card or in your notes, you can probably fill that in, and that's the answer to part A, and then simplify that for part B. That's all I have for you guys for section 1.7. Let me know with any questions you have.